How can you spot substandard electronic components? Imagine opening a device and wondering if every part inside is up to standard. Sometimes, hidden flaws cause failures that are hard to explain. Knowing how to spot substandard electronic components can save you time and money. It's like being a detective, searching for clues that reveal the truth about quality. When products fail unexpectedly, often it's because a component was not built or handled properly. These failures can happen in the field or during manufacturing. The key is to recognize the signs early before they cause bigger problems. Start with a visual check. Look closely at the component. Are there cracks, discoloration, or signs of overheating? Burn marks or melted plastic are clear hints of trouble. Check the labels and markings. They should be sharp, clear, and match the manufacturer's specifications. Faded or smudged labels could mean the part is counterfeit or recycled. Sometimes, counterfeit parts are made with cheaper materials or incorrect specifications, which can lead to early failure. Next, perform functional testing. Place the component in a circuit and see if it behaves as expected. Resistors should measure close to their rated resistance. Capacitors should hold charge and releases it properly. Transistors should switch and amplify signals correctly. If a resistor reads far off from its marked value or a capacitor leaks, that's a red flag. Testing is simple with a multimeter or a specialized tester, but it's very effective. Electrical characterization takes testing further. Use tools like curve tracers or multimeters to measure key parameters. For example, transistors should have a gain within specified ranges. Diodes should show correct forward and reverse bias behavior. Any deviation from the normal values indicates a problem. For integrated circuits, check the quiescent current and switching times. These measurements can reveal internal faults that are not visible on the surface. When visual and electrical tests aren't enough, advanced techniques come into play. X-ray imaging can reveal internal defects like broken wire bonds or voids in solder joints. Acoustic microscopy can detect cracks inside packages. Thermal imaging helps identify components that overheat under load, which may suggest internal shorts or poor materials. These methods are often used in failure analysis labs to uncover hidden issues. Material analysis is another step. Techniques like energy dispersive X-ray spectroscopy or Raman spectroscopy can identify if the materials inside the component match what they should be. Counterfeit parts often use cheaper or incorrect materials that can be detected this way. These tests help confirm suspicions of substitution or contamination. Context is also important. Consider how the component was stored and used. Was it kept in a dry, cool place? Exposure to moisture, heat, or mechanical stress can cause early failure. Sometimes, a good-looking part fails because it was mishandled or stored improperly. Reviewing the circuit design can also reveal if the component was subjected to conditions beyond its limits. In real-world failure cases, the process often starts with observing the failure, then isolating the suspect part. Testing it out of circuit and using advanced tools helps find the root cause. Removing the component and retesting the circuit can confirm if the fault was caused by that part. Sometimes, cutting traces or replacing the component is necessary to see if the failure disappears. Spotting substandard electronic parts isn't just about fixing broken devices. It's about preventing future problems. Identifying and removing bad components improves product reliability and safety. Many failure case studies show that early detection saves time, money, and protects reputation. Being able to recognize signs of substandard parts is a valuable skill for anyone working with electronics. It combines careful observation, systematic testing, and sometimes advanced analysis. This way, you can ensure only quality parts make it into the devices we rely on every day.